Welcome to Grade 10 Physics. This unit on force, motion, and energy in Grade 10 Science includes the electromagnetic phenomena all around us. You will understand the different electromagnetic waves, commonly known as the EM spectrum. You will have a detailed study of the characteristics, properties, and uses of the EM spectrum to appreciate the relevant applications and understand their effects to us and our environment. But before we start learning about the EM spectrum, let's learn about the characteristics of waves in general. Our learning target is, I can describe the characteristics of waves using the concepts of wavelength, velocity, and amplitude. What is a wave? A wave is a periodic disturbance that moves away from a source and carries or transmits energy without transferring matter. The disturbance is frequently called as oscillation or vibration. What are the types of waves? Waves can be classified into two: mechanical waves and electromagnetic waves. Mechanical waves has three types: transverse waves, longitudinal waves, and surface waves. Let us now discuss the first type of mechanical wave, the transverse wave. A transverse wave is a wave in which the oscillation is perpendicular to the direction the wave travels. Examples are waves in a piano strings, waves on a rope, electromagnetic waves, and some seismic waves. Now here are the parts of transverse wave: the crest, the trough, the amplitude, and the wavelength. The next type of mechanical wave is the longitudinal wave. A longitudinal wave is a wave in which the oscillation is parallel or along the direction the wave travels. Examples are sound waves, waves in fluids, liquids, gases, or plasma. A compression is a region in a longitudinal wave where the particles are closest together, while a rarefaction is a region in a longitudinal wave where the particles are farthest apart. Electromagnetic waves. Electromagnetic waves are transverse waves consisting of a combination of oscillating electric and magnetic fields, which are perpendicular to one another in the direction the wave is traveling. Electromagnetic waves transmit energy at the speed of light in a vacuum or without any medium at 3 times 10 to the power of 8 meters per second. Electromagnetic waves can travel through any medium. The range of frequencies and wavelengths is called the electromagnetic spectrum. It is generally divided into 7 regions in order of decreasing wavelength and increasing energy and frequency. The common designations are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Typically, lower energy radiation, such as radio waves, is expressed as frequency. Microwaves, infrared, visible, and ultraviolet light are usually expressed as wavelength, while the higher energy radiation, such as X-rays and gamma rays, is expressed in terms of energy. Here is a mechanical representation of a wave. The broken line is the equilibrium position. The crest is the highest point in the wave, while the trough is the lowest point. The distance from one crest to the next crest, or from one trough to the next trough, is called wavelength. Amplitude refers to the maximum amount of displacement of a particle on the medium from its rest position or from the equilibrium position. Here are the characteristics of a wave. Let us now compare the frequencies of a wave. What does high or low frequency mean? Let us compare wavelengths of a wave. What does short or long wavelength mean? Waves with long wavelength have low frequency and energy, while waves with short wavelength have high frequency and energy. Colors are light waves of different wavelengths and frequencies. What is the trend? From red to violet, the frequency and energy are increasing while the wavelength is decreasing. Thank you so much for attentive and cooperative listening. God bless you all.